Good morning. I hope everybody is doing well. I apologize about yesterday. I wasn't able to put a video up. I told you I would try to work on one every Monday, Wednesday, and Friday, and then review on Tuesday and Thursday. I apologize. I did not get around to that yesterday. Had a few things come up that I had to take care of. So like I said, I apologize about that. Today we're going to move ahead and begin lesson 5.2, verifying trig identities. And I know that it is spring break for you guys right now, and you're actually not required to work on this work during spring break, okay? But I just want to keep putting out the videos so when you do get a good start on it next week, you'll be ready to go, and you'll have plenty of videos and plenty of resources to look back on and be able to do that. So I understand if you're not working on it right now, that's completely fine. But next week we need to really get going with that since we'll be off spring break. Also, from everything I'm hearing, or not hearing, but the State Department, I think, is supposed to make an announcement at some point today. Today's Thursday, March 26th, about when schools may resume. So, we'll be waiting around for that. I don't know any more than any of you guys know. So, we'll just hear about that announcement probably at some point in time, and, may, change the process or kind of what we're doing. But, like I said, this class is for Gadsden State. So it's, we got to go by what they're doing and everything. So, like I said, we're going to, required to keep teaching. So today we're going to do this example one. It's called Verifying Trig Identities on page 202. This is always, when I start, students think, oh my gosh, I don't know what to do. This is so difficult. This makes no sense. I can't. I don't get it. But then by the end, by the time we practice, by the time we go through them, it's usually typically becomes students a concept that they enjoy, because actually here it says verify. Well, when it says verify, that means they're telling you, hey, this is true, okay, but you show me this is true, okay, and we show you that's true by using the trig identities. So that's kind of what we're going to look at, or it's not kind of, that's exactly what we're going to look at today, is how to verify these and all the different rules and steps and processes and things of that nature. So for this video today, I'm going to do the first two examples, and then tomorrow I'm going to probably put out examples 3 and 4, and I may even add 3 and 4. I may do 5 and 6 at some point too. So I'm going to try to work through those videos. I may do them over the weekend. I may not get one out tomorrow, but for today, we're definitely going to do examples 1 and 2, which begins on page 202 in your textbook. If you look on page 203, if you've got your book, there's hints for verifying trig identities, and there's 6 hints, very long list. I know you probably can't see this right now, but in green, kind of the shaded green, you can see that there is a long list of these problems, okay? And I'm just going to try to show you those, just by going through and kind of looking at them. You don't have to memorize the 6 steps, because they're not really steps, they're more suggestions, okay? And there's some shortcuts and some things that we can do from time to time to make these simpler, but for the most part, we just kind of have to, get in there and get them figured out. So at this time, I'll go ahead and begin with example 1. And like I said, we got 2 examples today. Excuse me. So today, the first example that we're going to look at is cotangent theta plus 1 equals cosecant theta times cosine theta plus sine theta. All right, now this is, for the first 3 or 4 examples, we're just going to be working with one side. And what I mean by that is, look at the problem and determine, okay, which side looks more difficult? Which side looks more scary? Which side do I not like? Okay, so that's what we got to ask ourselves, is which side looks more scary? And it's pretty obvious that this side over here, cosecant theta times cosine theta plus sine theta, is the scary side, okay? Now, A lot of times students, when they first start with this and they're not 100% confident with the trig identities, they'll see this side of cosine theta plus sine theta and they think, oh, that's 1. No, that's not 1 because it's not squared, okay? So this is still, we just got to leave it like this, okay? So now I've identified that this right-hand side is the more difficult side, all right? So what I'm going to need to do is I need to show that this is the same thing as cotangent theta plus 1, okay? So I need to show. So I'm not even going to worry with this side, okay? I can just write this side down all the way down to the bottom of the board if I have to. I know that side's not changing because I've said it's not the most difficult side, all right? So over here on the right-hand side, there's a couple different ways. If you look at your book, they may do it a slightly different way than I do, but it all comes back around and we all get the same answer, okay? Or again, like I said, our answer's already there. We're just verifying. So here I'm going to distribute, okay? I'm just going to do my distribution, okay? And like I said, there's probably a slightly easier way or could be an easier way, but for the most part, we're going to just do this. So it's going to be cosecant theta cosine theta plus cosecant theta sine theta. So I simply distributed the right-hand side, okay? That's all I did is I distributed the right-hand side. All right, now left-hand side I'm not touching. Okay, once I've done that, another one of the rules, another one of the problems, another one of the suggestions, I should say, from this page, again, another one of these suggestions, if you go through and you look at these, and maybe I can try to get this out to you guys some way, is to try to write everything in sine and cosine. If you don't know what to do, write it everything in terms of sine and cosine, okay? So, again, but everything in terms of sine and cosine that I'm working with. I'm not working with the left-hand side, so I'm just writing it down, okay? So again, I'm wanting this side to be cotangent theta plus 1. So I'm going to rewrite this in terms of sine or cosine. So cosecant, remember that's the same as 1 over sine, times, cosine's already in terms of sine or cosine. And then right here, plus cosecant, again, that's the same thing as 1 over sine theta times sine theta. Okay? So I can write those over 1 or whatever. You don't have to. All right, now we should be able to see this. We should be able to see what is happening, okay? Or if not yet, eventually once you start working some of these, you will. So right here on the right-hand side, this is 1 over sine times cosine over 1. So that's just cosine over sine. Multiply the numerators, multiply the denominators together. Plus, now look what happens right here. This side and this side cancel, okay? If you multiply this together, it'll be sine over sine, which is just 1, okay? So, cancels, so that's just plus 1. All right? Now, remember, we are verifying. So, I need this side, I need to show that it is cotangent theta plus 1. I've got it, guys, okay? It's there. It's there. Because cosine over sine is cotangent plus 1. So I have shown that this right-hand side is the same as this left-hand side. Okay? So please make sure that you see that. Please make sure that that makes sense. Please make sure that you're able to handle that concept. Again, because this is, one of the, obviously, y'all know how it goes with math, but this is one of the early problems, or one of the first problems, so it's one of the easier, but please make sure that you understand this, okay? All right, this time I'm going to clean this board off, erase it, and do all that stuff, and be right back to work example 2. Okay, so now we're going to move on to example 2. In the book, and this is again, this is on page 204, and I'm just working the examples out of the book, so you can kind of follow along maybe and kind of see how they do them and how I do them. If you see in the book, it's going to say, okay, we're working with one side, and that's the case. Okay, that's a real good tip. But you don't always just have to work with one side. I mean, sometimes it's just as easy to work with both sides and manipulate them that way. So there's no like standard way to do these. There's no way of saying, okay, here's what you do. This works every single time. We're good to go. Bam, you're done. Okay. There's really not. So the best way, or the way that I found that I like to look at them, is just first say, okay, which side looks more difficult? Okay, let's try to simplify that side. How do I simplify it? Well, let's try to change it to terms and sine and cosine. Okay. So that's how I always like to approach these problems. But I also, a lot of times with math, it's the fear factor of, oh no, I can't do this. This looks way too difficult. I don't get it. This makes no sense. We're talking about sine, we're talking about cosine, we're not got numbers, and it's craziness, okay? But what I want you to understand right here is they're giving us the answer, okay? The answer's there. Bam. These are equal. Show it, okay? And then we're going to talk about all those different strategies to show it, whether it be work with one side, make it look like the other side, work with both sides, make them work to a common goal, whatever the case may be. But the first thing I want you to understand is these are really not scary problems. They're really not that terrible. You just have to, you have to work through these. You have to give these a shot, and you have to at least make an attempt, or it will kind of be tough, okay? So let's look at example 2 here. And as you can see, I've got two sides, obviously, and I want to determine, okay, which side is the most difficult? Which side do I want to work with? Well, in this case, I'll be honest, guys, I don't know. One's a fraction and one's got, distributive property, okay? So they're both kind of difficult, so to speak, or they're both, it's not an obvious answer for that. But I guess if I was looking at it and say, okay, the left-hand side is kind of the more difficult side, because you're going to have to distribute and then combine and then add. And then, there's going to be various things of that nature that you have to do, okay? But you also want to just kind of look at it and say, okay, I've got a tangent and a cotangent. Okay, that's nice, okay? Because I can probably simplify, okay? I can probably do something. Maybe they'll cancel. I don't know. Maybe something takes place there, okay? So, let's go ahead and take a look at the left-hand side. So I'm going to distribute through this tangent, okay? I'm going to distribute through this tangent. So that becomes there and there. So that becomes tangent squared times 1. That's just tangent squared. Plus, okay, now I'm going to write this down, but it's tangent squared times cotangent squared. Okay? Okay? And I'm not even going to worry with the other side, because I've chose this side to work with, okay? Now, look at this, all right? I've got tangent squared, okay, I distributed, so I've got tangent squared here. And then this is the same thing, guys, as tangent squared x, right? Tangent squared x times 1 over tangent squared x. So this is really gone. It's just 1, okay? So on this side, I have tangent squared x plus 1, okay? So now you're looking at that and you're saying, okay, well, how does that equate to the other side? Because right, that looks nothing like the other side, okay? Absolutely nothing like the other side, okay? And I've done all the simplification that I know how, okay? There's really nothing else I can do, and I've got it down to that, and I'm saying, okay, well, that's tangent squared x plus 1. But wait, wasn't or isn't that some sort of identity? Tangent squared x plus 1. Is that anything? Is that an identity? And if you go back and you look on page 197, and again, I know you probably can't see this, okay? But you've got tangent squared theta plus 1. Well, tangent squared x, same thing, okay? Is equal. So this is simply secant squared. Okay? All this is simply secant squared. x. So the left-hand side, after I work this problem all the way down, the left-hand side is simply secant squared, okay? So tangent squared x, I'm sorry, I know y'all can't see that. Tangent squared x, okay? The tangent squared x, right? Okay, I apologize, maybe you can see that a little better. So now, the tangent squared x plus 1, that is just secant squared x, okay? So I've worked all that problem down, and now I'm looking at this other side saying, well, those aren't the same. I haven't verified. It's really weird to me. I don't get it. So even though on example 2 it says, hey, verify using one side, I'm going to take that right-hand side and I'm going to see if I can simplify it, okay? And I can, because if I look at this right-hand side now, so now look at the right-hand side. I got the left-hand side down to that. That's awesome, okay? That's good. That's where I want it to be. Excuse me. And now the right-hand side, look at this. This is 1 over 1 minus sine squared x. Well, again, according to the identities, this 1 minus sine squared x, guys, look. Okay? I know that sine squared plus cosine squared is equal to 1. So if I manipulate this, right? If I move that sine over, that is now 1 minus sine squared x is equal to cosine squared x, okay? So, again, remember, this right here, when we manipulate it, and I'm coming off to the side here, I'll write this in red so you know that this is actually not part of the problem. Sine squared x plus cosine squared x is equal to 1, okay? So, when I move the sine over, that gives me cosine squared x is equal to 1 minus sine squared x. So, this in the denominator is the same thing as cosine squared. Now, what is 1 over cosine squared? And again, we go back, we look at our identities, we talk about those, and this is on page 197, but if 1 over cosine is equal to secant, then 1 over cosine squared is equal to secant squared. So this is secant squared x. So I have shown that these two sides are equivalent. Okay? So that's the first two examples from this lesson. Okay? Not the easiest problems in the world, okay? But I promise, once you kind of go through them a little bit more, you'll understand and you'll see that they're not quite as scary as you maybe originally thought. But they can give some issues. Okay, so I'm just gonna give a few problems right here that I want you to try. Okay, typically speaking, we would go through and we'll do. We're going to end up doing a good number of these problems. I want you to try for today, just for these couple, because like I said, we've got probably 5 examples at least, and we just did 2. So I want you to try to do on page 209, and I'm going to add to this each day, okay? So please make sure. So page 209, I want us to just do for today, okay? And like I said, I'm really trying to simplify this down. Just try these odd problems, 45 through 51 odd, okay? Now I know that's only 4 problems there, and that's not a whole lot, okay? But until I do all 5 examples, it really doesn't make sense to give you every single one of these problems just yet. So I'm going to keep working through these. we'll try to do example maybe 3, 4, and 5 tomorrow. May have to do all 3 of them tomorrow, or it may be Saturday, guys. I apologize. Got a few things that came up that I've got to attend to, but anyway, so that's kind of the plan. And like I said, I hope to get back to school and see all you guys soon. I know it's crazy, like I said, crazy times, but we'll get through it. So I hope everybody is having a good spring break and everybody staying safe. We'll see you next time.